This is pre-algebra lesson 9-3, classifying polygons. A polygon is a closed geometric figure with at least 3 sides. Sides meet at their endpoint, and these are called vertices, which is the plural of vertex. Polygons are named by their vertices. You only start at one vertex and list in consecutive order, either going around the figure clockwise or counterclockwise. What is meant by a closed geometric figure? I've drawn a figure here. It happens to have 5 sides, so it's a pentagon, which we'll discuss later on how you name them, by other than the vertices. But as you can clearly see, it's closed, which means there's no gaps. If I was to draw a figure like this, if I was to draw a figure like that, that would not be a polygon because it has an open space. This is not a polygon, okay? Because of the fact that it has an opening. In order to be a polygon, each side has to connect with every other side, okay, or with at least 2 more sides. So they have to be connected. There can be no holes in it. Now this polygon here, if we wanted to name it, I could start with the letter C. If I started with the letter C here, I could go that this is pentagon. And I could name it by the letters. I could say C, B, A, E, D. Or I could name it C, D, E, A, D. As long as I start with a letter and I either go around the figure this way, or I go around the figure this way, we're fine. You can't go across the figure because C does not connect with E, so I can't go that it's labeled C, E, A, D, B. That would be incorrect because you have to name it consecutively. The sides have to touch each other. So C touches B, and B shares a side with A, and A shares a side with E, and E shares a side with D, and D shares a side with C. So that's how you can go around it. A regular polygon is a polygon in which all the angles and all the sides are congruent. Okay? So I have all these congruent sides here. And I have all these congruent angles here. So this is actually a regular octagon, otherwise known as a stop sign for most of you. Okay? So it's a regular polygon. All the angles are congruent and all the sides are congruent. Polygons are named by their number of sides, and you do need to memorize at least the first 5 or 6 of these. Okay? If it's 3 sides, it's a triangle. 4 sides is a quadrilateral. Don't think that 4-sided figures are named rectangles, because not every 4-sided figure is a rectangle. There are some specific types of 4-sided figures, which we'll get into in later lessons. Pentagons have 5 sides, hexagons 6, heptagons 7, octagon is 8, nonagon is 9, decagon is 10, undecagon is 11, and a dodecagon is 12. All of these are based upon their prefixes. If you look carefully at their prefixes, okay, tri, quad, penta, hexa, hepta, octa, nona, deca, undeca, and dodeca. Those are all prefixes for their number. Tri means 3, quad means 4, penta means 5, hexa means 6, and so on. So if you know the prefixes, you'll know how many sides a figure has. Any polygon more than 12 sides is simply named by the number of sides. The suffix gon can be put at the end of it. For example, if it has 12 sides, it would be called a dodecagon. But if it had 13 sides, it would be called a 13gon. If it had 42 sides, it's a 42gon. If it had 177 sides, it'd be a 177gon. Simply put, once you're past 12, you just add the word gon after the number. Now, triangles, which are 3-sided polygons, can be classified by either their sides, their angles, or both their sides and their angles. And we're going to talk about different types of triangles. An acute triangle, just like an acute angle is an angle less than 90 degrees, an acute triangle is a triangle with all the angles that are less than 90 degrees. It's pretty obvious, that's an acute triangle. I don't even have to label the angles, we know it's an acute triangle. Okay, it can be like that, it can be like this, all those are acute. It can be tall and skinny like this, that's an acute triangle. A right triangle is a triangle with exactly 1 right angle. And of course you have to label the right angle to prove to somebody that it is a right triangle. Right triangles can look like that, they can look like this. It has to have a right angle in it somewhere. Doesn't matter where that right angle happens to be. It's still a right triangle. An obtuse triangle is a triangle with exactly one obtuse angle. It can only have one. Just like a right triangle can have exactly one right angle, an obtuse triangle can have exactly one obtuse angle. And it's pretty obvious which is the obtuse angle. It's the big one. Now we'll talk about, that's the classifying triangles based by angles. Now we're going to classify triangles based on their sides. A scalene triangle is a triangle that no sides are equal in length. So I could have something like this. Okay, this is not equal to this, which is not equal to this. It's a scalene triangle. Okay, no equal sides whatsoever is with a scalene triangle. Okay, it looks like this, it looks like this. But there are no equal sides. An isosceles triangle is a triangle with at least two equal sides. Okay, so I could have something that looks like this. This side is equal to that side. I can have something that looks like this. This side is equal to that side. It has to have at least two equal sides. And I'm going to put two lines here because they're not equal to the other one. An equilateral triangle is a triangle with all three sides of equal length. And I want to make sure I get this perfect. So I'm going to just grab one from the figure here. And we have an equilateral triangle. Okay, all three sides are equal in length. Therefore, I can label all three sides being equal in length. And we have an equilateral triangle. Quadrilaterals. Now, here's what I told you later in the lesson. I said we would talk about quadrilaterals because not all quadrilaterals are squares. Quadrilaterals can be classified by their sides and their angles as well. All quadrilaterals have four sides, which each have some distinct features that set them apart from all the other quadrilaterals. For example, a trapezoid. A trapezoid is a quadrilateral with exactly one pair of parallel sides. Only one pair. Okay, this side is parallel to this side. The other two sides are obviously not parallel. And there's many different ways you can draw trapezoids. Okay, this is a trapezoid right here. This is parallel to this. Okay, still only one pair of parallel sides. A parallelogram, on the other hand, is a quadrilateral in which opposite sides are parallel. It kind of looks like a rectangle falling sideways. Okay, we have this line parallel to this line over here, and this one here parallel to this one here. Okay. A rhombus is a quadrilateral with opposite sides parallel and all sides equal in length. In other words, a rhombus is an equilateral parallelogram. Okay, it's a parallelogram with all sides being equal, so you have to tell me that the opposite sides are parallel. There's a lot of labels to a rhombus. And then you have to tell me that all sides are equal in length. Okay? It's somewhat like a leaning over square. Okay? But it's called a rhombus. Some people refer to it as a diamond. It is not a diamond. It is a rhombus. There is no geometric shape called a diamond. A rectangle is a quadrilateral with opposite sides parallel and all angles 90 degrees, otherwise known as an equiangular parallelogram. It's a parallelogram in which all the angles are equal. So we have opposite sides are parallel, and all the angles are 90 degrees. So that creates a rectangle. Now, if you want to make it one step more specific, we have what's called a square. A square is a quadrilateral with opposite sides parallel. All four sides are congruent, and all four angles are 90 degrees. It's otherwise known as an equiangular equilateral parallelogram. So opposite sides are parallel. All angles are 90 degrees. And all sides are equal. And that's what a square is. A square is more defined than a parallelogram. One way to tell people about this is if I was to describe some animals like dogs. Okay, there are lots of dogs. I could say, ooh, look, there's a dog. That would be like saying, ooh, look, there's a quadrilateral. And then I could be more specific and I could go, ooh, look, that's in the toy group of dogs. And you go, oh, that's in the toy group of dogs. Toy would be more like saying, instead of it's a quadrilateral, now we're saying it's a parallelogram. It's a bit more descriptive than our quadrilateral. Then I could go one further and I could say, oh, look, it's a miniature poodle. That's even more specific. A miniature poodle is a special type of toy dog, a toy animal that fits in the dog category. So it's even more specific. It would be like saying, oh, that's a square. A square is a specific type of parallelogram, and the parallelogram is a specific type of quadrilateral. Okay? It's easy to say things that way because I can always tell you, okay? Every square is a parallelogram, but not every parallelogram is a square. And that sometimes confuses people, but think about it this way. Every poodle is a dog, but every dog you meet on the street is not going to be a poodle. Poodle is more descriptive in the dog category. Square is more descriptive in the quadrilateral category. So every square is a parallelogram, but not every parallelogram is a square, because some parallelograms are rectangles, and some parallelograms are just ordinary parallelograms. All right, once we know these definitions, we need to be able to classify things. Classification, just like science, means you're going to group it, and you group it by giving it a descriptor. For example, we're going to classify each triangle by its angles and its sides. Okay? Sides and angles. It doesn't matter which one you put first. So if I look at this first triangle here, I go, it doesn't look like any of the sides are equal in length, but I do have a big obtuse angle here, don't I? So we know that the triangle is obtuse. I also know that none of the sides are equal in length, so this would be considered to be an obtuse scalene triangle, or a scalene obtuse triangle. We call it obtuse scalene, or you can call it a scalene obtuse triangle. It doesn't really matter which one comes first, the sides and the angles. But we've described it by its angle, which would be obtuse, and the side lengths, which are scalene, because none of them are equal. If we look at number 2, we see that all of the angles are 60 degrees. We see that all of the sides are equal. 60 degrees means it's acute, so it's an acute triangle. All sides being equal means it is equilateral triangle, so it's an equilateral acute triangle. I just can't spell equilateral. There we go. Equilateral acute triangle. There's the symbol for triangle. Triangles actually has a symbol. It's a small little triangle. If we look at number 3, we can see, it has acute angles, but it also has a right angle. Since it has a right angle, we name it being a right triangle, because the right angle supersedes the acute angles, because in order to be acute, all 3 angles have to be acute. Only 2 of the 3 are acute, therefore it's a right triangle. It has 2 equal sides, so it's called an isosceles triangle. So this is an isosceles right triangle. Or it's a right isosceles triangle. I actually normally refer to them as isosceles right. I don't know why. It's probably the way I learned them, so that's the way I've stuck with it. It makes no difference. It's either isosceles right or it's right isosceles. Let's take a look at this next picture. It says a contractor is framing the wooden deck in the shape of a regular dodecagon. Dodecagon. How many sides? If you don't know, count. Count the number of sides in your figure. It's 12. Write a formula to find the perimeter of the deck and evaluate the formula for a side length of 13. Well, if it's regular, that means all the sides are equal, doesn't it? It means all these little sides here are equal, which is nice because that makes it easier to find the perimeter. We're supposed to write a formula. If you remember, perimeter is all the sides added together. Okay, so the first thing I'm going to do is I'm going to define a variable. I'm going to let x equal my side length. Okay, and if x equals my side length, and I have how many sides to this lovely perimeter? I have 12 sides. So the perimeter, if you remember, perimeter is all the sides added up. Add all side lengths. So basically, my perimeter is x plus x plus x plus x plus x continuing on for 12 x's. Or, easily said, perimeter is 12x. 12 sides times the side length equals my perimeter. There's my formula. So if that's my formula, if each of my side lengths is 13, I can find my perimeter. My perimeter then is going to be 12 times 13. So if I take 12 times 13, I'm going to get 156. So my perimeter is equal to 156. And I look at it, oh, it's in feet. So here's my formula. Here's evaluating it for the length of 13 feet. Which we made this a whole lot easier because we knew a dodecagon was 12. All right, it says name the two types of quadrilaterals that have 4 right angles. Well, think about this. What types of things have 4 right angles? We have parallelograms don't, trapezoids don't, but rectangles do, and squares do. So this would be rectangles and squares. Alright, so now it says, whoops, off the screen, write a formula to find the perimeter of a regular hexagon. Right, and I specifically did not draw a picture for this one, because I have to think about it for a minute. A hexagon, if you remember, hexagon. Look in your notes if you need to. A hexagon equals 6 sides. Regular means all the sides are equal, which means if each side was 2 feet long, then we would do 2 feet plus 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 2 feet. Right? So since all of the side lengths are equal, I'm going to let x equal the side length. So my formula for the perimeter would be P equals 6 times x, because whatever my side length is, I'm going to multiply it by 6 because I have 6 equal sides. This is polygons. Polygons can be many-sided. Remember, they have to be closed. We talked specifically about triangles and quadrilaterals today. Polygons with 3 sides and polygons with 4 sides. Again, remember to review your vocabulary because there's a lot of it in this chapter, and it is crucial to understanding all the different things, and you will be quizzed on it.